Hello, my name is Ayana Scott-Elliston. I am a Savvy Coders Bootcamp student who is presenting their Capstone project from the Data Analysis and Python Bootcamp. My Data Analysis and Python Bootcamp presentation will be on chronic diseases and their indicators in the United States. Now, first, let me give a little introduction to myself and my project. So, I have a background in biological sciences and health sciences. My bachelor's of science was in biochemistry. I have two masters, and both of them were in the health sciences. One was in microbiology, and the other one was in zoology. My most recent job was with fertility clinic Kindbody. And while I was with Kindbody, I had the opportunity to work with patient data. So when I was working with patient data and assessing what we had, I realized that we collect so much data, whether this is in the laboratory or whether this is in the patient-facing side on our patients, but not all of that data is able to be accessed and assessed and for decisions to be made around that data that we're collecting. So I decided to pivot into data analysis, and that's why I took this boot camp. So then once I'm in this boot camp, I decided, hey, I want to focus on asthma. Asthma has personal connections with me. I have family members who have asthma. I know a lot of friends who have asthma. And so I decided I wanted to look at asthma and air quality. But as I was looking for a public available data source using Kaggle and data.gov, I realized for asthma, they usually have the data specific to states, but I wanted to look at the entire United States. So I found this other data set called chronic diseases and their indicators in the United States. And when I found this data set, I was completely surprised how many chronic diseases exist in the United States. I did not know. I thought there were a few like cancer, but I didn't realize there were so many that are impacting people in the United States. So I altered my question completely to what are the chronic diseases in the United States? How prevalent are the chronic diseases in the United States? And my hypothesis was that chronic diseases are more prevalent in states with less regulations around air quality, water quality, and other environmental factors. Now for my data manipulation methods for cleaning. So first thing I did was I took my Excel, I took my comma separated value file for chronic diseases and I opened it in Excel. I did a pivot table to see what columns were lacking data because I assumed from the front there's going to be random columns people added expecting that there would be data inputted in there, but that there weren't. And I found it. So the response column had no data in it. The stratification category 2 column had no data in it. The stratification 2 had no data in it. So then from there, I was like, okay, I can go straight to Python. And I created a Jupyter notebook. And the Jupyter Notebook was how I tracked every stage of my data analysis. For the boot camp, I was in my Agile ceremonies, I was the Scrum Master. So as a Scrum Master, I was helping people get through their blockers. I was helping people figure out what they needed. I was helping people stay motivated so that they continue what was necessary. So I just did the same thing for myself. So I created this file in Jupyter Notebook, and every step of the way, every time I had a problem, I made a note of it and I tried to figure out my blocker and then continue on. So in the notebook in my Python, first I imported pandas and I gave it the alias as PD. Then I imported NumPy and I gave it the alias as NP. Then I imported the value, the comma separated file for my data set into Python. And then I gave it the variable name chronic underscore disease. And then I just want to take a quick peek at my table, chronic underscore disease, and I just opened it. And when I opened it, I could see I started with 309,215 rows and 34 columns. So that's what my data set was before cleaning anything. Then from there, I wanted to double check if the nulls I was seeing in the pivot table, if they matched. So I did chronic underscore disease dot info. And from there, I could clearly see, that there were the null rows, the ones that had no information. In this case, it says zero non-null, which means that there's no data in that column. It matched. But then I also noticed that for certain columns, there was less rows with data than in the other columns. So I was like, okay, I know that these are columns I'm going to have to go back to and assess to see exactly what's going on when I'm doing my cleaning. So here's an example. I was dropping a row. This row I dropped was for all rows that had no null that basically had nulls in it for data value. And the reason I knew I could drop these ones with the data value one was because I had checked in the file because I had a data wrangler and opened a separate table so I could look at it row by row. And I could see that for the ones that had nulls, the data value in there, the footnote symbol that just marked that there was an issue. And the data value footnote would say a note. And the note would say something, a few of the options were not enough data was collected to complete the study, or no data was collected at all. And that let me know it was okay. I could completely remove those because one, they have no data in it, that's confirmed by the footnote that tells me that it has no data in it. So it's okay to remove those rows. Then after several iterations of cleaning, the final clean data set was 184,348 rows by 22 columns. From there, I imported that into SQL. The SQL we were using was SQLite. And I, of course, did a quick peek assessment for table info just to see if what I did matched what was cleaned in Python. And then I brought up the table completely by doing the select asterisks and the file name. But initially, I was going to remove the index table called field one because it popped out of nowhere. It wasn't there initially in my actual data set. And then it not only popped up, there was an additional field that I looked and saw that popped up at the end. And I was trying to figure out what exactly happened. I had no idea what happened. And that was a mini blocker because I was like, how am I going to clean all these rows if there certain rows are shifted? And I found out after talking with one of the teachers that that additional row happened because of a standard operating procedure in SQLite. So SQLite for comma separated files, they separate by comma, but you could choose different separators. For my file, everything was comma separated, but the strings were was the issue. So for my strings, instead of the standard single quotes, which is what the standard SQLite is, it's a single quote separation for strings. My file was using double quotations to separate strings. So because of that, things were getting completely shifted. But once I knew that, I quickly was able to adjust that and fix it. But then there was the other issue. I had tested out my data set after fixing that issue in Tableau, but in Tableau, the geolocation, which was in my file as a single um, value, was not working. For Tableau, it needs the latitude, longitude to be separate columns. So I had to create two separate columns, which I created the columns itself, the names of themselves in SQL, and then I used Excel and I used code to separate it out. So first thing I did was I had to delete the point because for my geolocation, they added in the word point, which made it a string. So I had to remove the word point, and then I had to delete one section and shift and delete one section and shift to get latitude, longitude into the two separate columns. Now for the data. So after all that cleaning, I imported it into Tableau, and this document is for number of records for each state. So this has a kind of like a heat map essentially. So if it's deep yellow, it's 684 records, and then it goes up and goes from into lighter yellow to white and to light purple and to the deep purple. And the deepest purple, the maximum amount of records is 4,208 that was found in this data set. So you want your records to be generally around the same number, which for Alaska is 3,366. Nebraska, 364, 300, 3,641. For Oklahoma, 3,910. So for this data set, you pretty much have them all within between 2,500 and 4,000, which is a lot of data to have that many. Each one of those records is a separate study. So all of these states have a strong dearth of information about these chronic disease topics. So you know it's okay to look through this and actually run some stats on it. Now for topics assessed. So there are lots of topics assessed: alcohol, which I didn't even think about for chronic disease, arthritis, asthma, cancer, cardiovascular disease, chronic obstructive pulmonary disease. There were so many chronic diseases that were assessed as topics. But each one of these chronic diseases had separate questions that they were evaluating. So even though this is average prevalence, since this is like multiple questions, we can't say anything. Is this bad? Is this good? We don't know yet until we actually see the questions. And then for these studies, they use different units for the studies. They use percentage, which I have clicked right now. They use cases per 1,000. And that was a problem because then I'm not sure, hey, have all of these, are all the studies equal, or are all the studies using the same units? Are there any gaps in which studies have the cases per 1,000 versus the ones who have years? So I then had to make a decision about which studies I was going to actually use based on their units. So that's why I did this chart. And in this chart, I could clearly see that for the different conditions like alcohol, arthritis, asthma, the cases per thousand studies, none of them were performed. And had I just like continued on with my study without checking this, I would think that there would be like zero or like no prevalence for a certain condition based on the data, or like less of, because it would decrease the overall average, without realizing that that difference was purely because, hey, the study wasn't done. So when I moved forward from here, I only used the data value percentage because I could tell clearly all of the topics had the studies done with prevalence based on percentage. You could see some have like a higher average prevalence, but what was important was that all of the studies were studied using percentage. There was a good amount, so I can move forward only using that unit for the rest of the presentation. Now for prevalence. So I have two similar kind of heat maps. For the United States, I have one that's per field, per topic. I have it marked right now for health status, and I clicked one of the health status, which was like two or more chronic diseases, and you could quickly see, the percentages for that. I will later talk about what there's an issue with this that I want to improve with Tableau, but I will talk more about that later with my challenges. Okay, now for prevalence per state. So I wanted to pick a particular state to look at. So I did basically all of the topics, and I wanted to see the state that had basically the highest prevalence on all the topics discussed. So that way, this would be a good example to look at and compare, since it has such a high prevalence for everything else. And for that, it was West Virginia with an average prevalence for all of those topics of 34,599. So West Virginia at a glance. So for mental health, we can actually now see the questions. So you have current poor mental health among high school students, depression among adults, frequent mental distress among adults, and postpartum depressive symptoms among women with a certain live birth. So this is what was making up that percentage for maternal health that we saw earlier. So we had for the mental health, 38.08% have current poor mental health among high school students, which is super concerning. And that kind of information is important for how we can design studies, what studies we should be looking at for a particular state, for funding agencies, how we can start actually solving the problems and filling the gaps. And for this, because this whole thing is editable, you could just pick another one. In this case, for asthma, there's only one asthma question: current asthma among adults, which for adults, they had 14.83%. And you can do the same thing for you, which you couldn't see before. And nutrition, and physical health, there's so many things they were assessing. There's so many questions. So this is for this file, when I upload it to Tableau Public, you can just click and get an idea of like, hey, as a funding agency or as a government agency, what should I start working on or planning to work on for my state to help my people? Now, I'm in St. Louis. I'm in Missouri. So I was like, hey, let me look at Missouri because that's super important. This is where I am, and this is where I can actually get some good work done. So right now I have it marked yet again: mental health, depression among adults. Depression among adults, 24.153%. For Missouri, they looked at frequent mental distress among adults is 18.428%. They like, if you change it, you can look at Health status, two or more chronic conditions among adults, 20.653%. That's a lot of people with more than one chronic disease within Missouri. So this is a good file that you just click around, figure out what you want to look for, what things are super concerning within our community group. And then I decided to compare West Virginia, which had such basically the highest percentage of all the topics discussed, to Missouri because it let us know where we stand as a state. For Missouri, for depression among adults, comparing that to West Virginia, we're at 23.44%. They're at 27.453%. So we're not far off from a state that is super struggling in regards to depression. So that's maybe something we should start addressing. What are the key indicators that lead to depression in the state? How can we fix those? For frequent mental distress among adults, 19.068% with West Virginia at 22.659%. So in this file, you can just click around, pick which chronic disease you want to look at, and then compare it to a state that you know has a pretty high one to say, hey, this is probably what we should be addressing. And for this, you can also click around for year. The year start I marked it at as 2022 and 2022 would be the start year. And I have all these marked that way. When I quick switch, it's easier. So the year end would switch, but since 22 is the most recent data set, that's how much information we have for the most recent amount of information. So this value we're seeing right now for depression among adults, that is a recent value. It's only like 3 years old. So that is super concerning. Only 3 years old. We're there. How far have we gone since there? So we probably have a lot more to work on than we did in 2022, considering everything that's happening with the world, with the environment, with the tornadoes we just experienced. Um, so this is a file you just click where you want and edit it regarding timeline to see where we were versus where we are and look at the topics just to get an idea of where you should probably look in regards to your research. Now for the challenges. So refining my question, which I mentioned earlier, I'd started thinking about asthma and environmental conditions, but quickly I had to change that. So I realized with the data set I had, I was like, hey, we're gonna look at all the chronic diseases because now I can actually address the United States as a whole versus just addressing single states. And I feel like addressing the United States as a whole is more beneficial for public health than just looking at individual states and their condition. Because if we look at the whole United States, it gives us an idea of where we stand compared to other parts of our state and how we can improve to become like some of the states that have less of these particular issues. So that refining my question was a challenge. The geolocation and data set included string. I mentioned that earlier. That was a challenge, like noticing that it was going to be treated like a string, which it was treated like a string in Tableau. I had no idea. And then I had to quickly, edit it. And I edited it, as I mentioned, in my manipulation methods using both SQL and Excel and creating two separate latitude and longitudes, which could be used in Tableau. But I found out apparently it could not be used in Tableau because Tableau has a glitch which I'll talk about in a second. So data set using non-standard quotation separation, that was a challenge. I hit that that road bump or blocker, essentially going from knowing that the SQLite has a standard acceptance of a single quote for strings, but for my data set, it came with double quotes. So that's something I will now know to look for in my data sets. And it was a challenge I faced and I fixed and moved on, and it was great. Now for Tableau, this I'm going to post on the Tableau public site. So Tableau has a habit of rounding behind the decimal. So for my latitude and longitude, it took that from my comma separator file, which had all of the decimal places behind the decimal, which is around 18 to 20 decimal places behind the decimal, and it rounded it to 4. So it could not actually do any of the locations with those latitudes and longitudes because it was missing so much data behind the decimal place. So what I did was I took the state, because I didn't know I could do this until I found out. I took the state and then I put it into Tableau and using the state, it was able to auto generate the latitude and longitude. But sometimes you're not looking for just a state, you're looking for a specific location in the state. So you want that original lat and longitude data. So that's something that needs to be addressed within Tableau. And I'm going to post about it to figure out, hey, are you guys working on this? Is there a fix already in place? Because I didn't find one. Also, not overloading my project. So I initially wanted to do two things at the same time with two separate data sets, look at environmental factors at the same time as looking at the asthma, the condition, which eventually became chronic diseases. And I couldn't both look at chronic diseases, which are so massive as a topic, and look at the environmental conditions. So I had to basically do an agile moment of being like, hey, I want to go from this bicycle to this like train, and that's too far of a jump. So how about I just take this bicycle and I go to a scooter? The same thing as like when I started with my raw data, I had a skateboard and I moved that skateboard to the bicycle. And then eventually what I'm going to do is move the bicycle to a scooter. But I was trying to jump all the way to a train. And I realized I had to cut that back so that at every stage I had something that was usable that could be worked through and that was workable, which I learned through Agile, which is a great lesson to not go further than you need to go. You can do things sequentially and have a viable product at every stage. So thank you for that. Next steps, which I'm excited about. So I'm going to determine a method to allow tooltip to show multiple results instead of an asterisk. Earlier, when I had my map that showed the field at the top and the question at the bottom, I want that to be all one map. But because of the standard feature in Tableau is that they'll put it as an asterisk if there's more than one value from it. In this case, more than one question present. So I'm going to determine a method to allow tooltip to show all of them. Then I'm going to also focus on a specific chronic health topic and its corresponding questions for Missouri. Just with one chronic health topic and focusing it down, I can then actually research what environmental factors can cause that chronic health condition and also can think of ways that it could be addressed. So that's why I'm going to focus on a single chronic health topic. So after I've focused on one chronic health topic, I've researched those environmental factors. I'm going to find a data set that matches that goal. There may not be, so I might have to go back up and switch to a different chronic health topic and find the data set that actually matches that. So we're going to see. After I pick my data set, I'm going to clean, analyze, and visualize just like I did for my earlier data set, this chronic health indicators data set, which I just presented to you. And then I'm going to go from there. It was a very exciting ride. I really do like the methodology of Agile. Just instead of always trying to push too far, you do small chunks to ensure that every time you can use what you have, which is a lesson I really needed because I was used to a lot of parts of different fields where it's just like we would rush through things and we wouldn't always have a viable product at every stage. But this agile method is super helpful. And thank you for that. So here are my references. The first reference is for the dataset itself. I got it from data.gov, but the dataset that was actually came from the Center for Disease Control and Prevention. So it was imported into data.gov since it's publicly available data. And the two other documents are the ones that basically brought my interest into picking this as a topic for my capstone. So thank you for your attention and listening to my presentation. I hope you have a wonderful day. And if you have any questions, you can totally message me. Thanks. Bye.